Hi, welcome back to the channel. So we're going to continue looking at double integrals, and what we focus on in this tutorial is double integrals in polar coordinates. Okay, so sometimes you are required to change a double integral from Cartesian to polar for you to be able to continue with the evaluation. Okay, so among the examples that we are going to look at, these are among the examples that we are going to look at right here. So they are pretty interesting questions. Okay, so I've picked question 1a, question 1b, question 1c, and question 1h. So if you observe, question 1a and question 1c are more like similar, and I'm specifically talking about the limits of integration because uh, that's what actually is interesting about these questions, and that's what you need to pay attention to is the limits of integration. Then question b, 1b is a bit is unique, it's just on its own. Then question 1h is the kind of like similar to g, but I've just picked h. But you can mirror what I'm going to do on h on G, and you're still going to get something that is correct provided you follow all the steps. So there's a reason why I've done this is because each of them appears to be a bit kind of like unique, and when it comes to changing from Cartesian to polar, it's important that you understand how you come up with the limits of integration. That is after you change from Cartesian to polar. And someone might be asking themselves right now to say, why should I even be changing from Cartesian to polar for me to be able to continue with the evaluation or to continue with the integration? I have two simple answers for you. Two simple answers. The first answer is, okay, the first answer is it might be a requirement. Okay, it might be a requirement in an assessment. It may be a quiz, a test, or an exam. It might be a requirement, even when it's not necessary. Keep that in mind. Sometimes converting or changing from Cartesian to polar is not necessary at all. You find that even evaluating or integrating in Cartesian is way easier and like straightforward compared to you changing to polar. But if it's a requirement, go ahead and do the changing. Okay. The second answer or the second reason for you changing from Cartesian to polar is it makes some integrals much easier. Okay, it makes some integrals much easier. There are some integrals that are complicated, and you're going to observe that when we do some examples under triple integrals. Um, some some integrals are complicated. They are too huge for you to be able to use Cartesian. So if you take them to polar, they are going to be much easier. Okay, so those are the two answers. Sometimes it's a requirement, even when it's not necessary. Secondly, sometimes it makes your work much easier. So let's go ahead and look at these examples. There are four examples. So the first one that we are going to do is say you are given that was question 1a, I think, from -1 to 1. Then in the inside part you have 0 to the square root of 1 minus x squared dy dx. So first things first, the idea is just about changing uh, the limits of integration. Then for this part, this is pretty straightforward. This is just going to change to what? To r dr d theta. Okay, now since we know what this one is going to become, let's go ahead and change our limits of integration. Okay, so the best thing or the best way to approach such questions is to sketch the limits of integration that you are given in Cartesian form. Okay, so let's go ahead and sketch them. So we have this, let's say we have this as our vertical axis, like that, and this as our horizontal axis. Okay, so in terms of y, since that's y there, these limits that you have here are in terms of y. It's like just try to observe them or try to view them as functions. Of course, this is more like 0 less than or equal to y less than or equal to the square root of 1 minus x squared. But when you view them as functions, it's just more like you have y is equals to 0 and y is equals to the square root of 1 minus x squared. And for simplicity purposes, don't try to kind of like plug in values here and there. It might confuse you. The best thing that you can do is just square both sides. This is going to be x squared, sorry, this is going to be y squared is equals to 1 minus x squared, and you can bring the x squared on the other side. That's going to be x squared plus, sorry, that's going to be y squared plus x squared is equals to 1, which is simply a circle of radius 1. Then let's look at the x, these limits for x is from minus 1, okay, to 1. So meaning you have x is equals to 1, and you also have x is equals to negative 1. Okay, so let's go ahead and sketch this. So let's say we have that as negative 1, and we have that as positive 1. So this right here, I'm naming it as my x is equals to 1. This right here, I'm naming it as x is equals to negative 1. Then remember to say this is your y-axis and this is your x-axis. You have a point at which, or you have a line at which y is equals to 0. This one here is y is equals to 0. Okay, then the other one is this circle here. Okay, so this circle is supposed to be more like, it has a radius of 1, so it's just supposed to be within that region there. But I'm more interested in the top part here, just this top part, like that. Okay, so why am I not interested in the bottom part? It's very simple. The reason is very simple. It's because if you look at the limits for y itself, it's this one and that one. So you're not interested in the bottom part. That's what we are trying to say. So now let's go ahead and come up with the limits of integration, which is in terms of r and what, r and theta. So for r is the easiest to find in most cases sometimes. So most especially when it comes to such. So r is just the furthest distance that you can get from what, from the origin, and in this case the origin is what, is this one. So the furthest you can go, you observe to say, no matter what you pick, whether you do that, you do that, you do that, or you do that, it's always going to be 1. Okay, so it simply means r, you are starting from 0. Okay, you're starting from 0 and you're going all the way to what, to 1. We have gotten the limits of integration for r. Then let's look at our theta. Our theta is very simple. You're just starting from this point, going all the way to what, to that point. Okay, and you observe to say at this point, this is like 0 to what, to pi. It's as simple as that. So you are going to have your theta here from what, from 0 to pi, like that. Okay, and I believe since 0 is equals to 2 pi, if you put 2 pi there, it's going to work out. Okay, okay, so we now have what we were looking for. We can go ahead and do the evaluation. So this is going to be, for theta, we said we are moving from 0 to pi. Then for r, we are moving from 0 to 1. Then here it's just like a 1. Then it's going to be, this is going to change to r d theta. So this is going to be r d theta. So let's go ahead and integrate the inside part. First, from 0 to pi, when you integrate the inside part, this is going to be r squared over 2. Evaluate from 0 to 1, then you have d theta there, like that. This is actually straightforward. So this is going to be when you evaluate there, when you plug in 1 there, that's going to be a constant, and it's just going to be more like 1 squared over 2, which is 1 over 2, a constant. So bring it outside, that's going to be 1 over 2. Then you're going to have 0 to pi d theta, like that. So this is going to be 1 over 2. Integrate that with respect to theta, like there's a 1 there, that's going to be theta. Evaluate from 0 to what, to pi. Then 1 over 2, you plug in, that's going to be pi minus 0. You observe to say your solution is just equals to pi over 2. This right here is your answer. You are done, just like that. Okay, so let's look at our second example. We look at our second example. So it's a bit similar to what we are from doing, just that it's a bit bigger. Okay. So if you think I've gotten something wrong on any of them, feel free to like help us with the correct thing. I mean correct answer in the description, not description, but the comment section. Sorry. Yeah. So this one is from 0 to 1. Then um, then we have from 0 to the square root of 1 minus y squared. Oh yeah. This is a bit different. Yeah. So this is going to be x squared plus y squared dx dy. That one was dy dx. This is dx dy. Okay. So now let's go ahead. First things first, sketch the limits of integration that you are given in Cartesian. So we have our vertical axis, horizontal axis there. Okay. So remember, for x, these are for x, then these are for y. So for x, it's more like you have like 0 x, okay, then you have the square root of 1 minus y squared. Okay, what this tells you is that this is just simply x is equals to 0, um as well as x. That's a circle actually, like the same way I did in the second one, just square both sides. This is supposed to be x is equals to the square root of 1 minus y squared, but when you square both sides and move the y squared on the other side, it's going to be x squared plus y squared is equals to 1. It's the circle of radius 1. Then for y just more like 0, you have y, so 0 to 1, so that's going to be y is equals to 0 and y is equals to 1, like that. Okay, so now let's go ahead and sketch this. So that's y-axis and that's our x-axis. So we have y is equals to 1 at I can just put it, let's say at this point right here. So I can name this as y is equals to 1, and you observe to say your x-axis is simply y is equals to 0. Then since I have x is equals to 0, you observe that your y-axis is simply x is equals to 0. Then for our circle, which is centered at the origin, it's supposed to go like, it has a radius of 1, so it will obviously pass at this point, which is 1 in the y-axis, like at that point. But I don't really have to go as far as this, like during the entire circle. I'm just interested in this part right here. Okay, something like, okay, why am I failing to draw something perfect? Okay, it doesn't have to be perfect anyway. Okay, that's, I can do better than this. Ah, but I think if you have a pencil with you, this is going to be much easier compared to me. Okay, like that. That's my area of interest. Okay, so now what does this tell us? Okay, this is the region now that we are interested in. So let's go ahead and pick the value of r. Remember, the value of r is the furthest you can move from the what, or the furthest you can project from the center or the origin. So in this case, like, you're going in this direction, and you observe to say you are starting from 0 to what, no matter how far you go, you're always going to be limited by 1, which is the radius of the circle. Even if you come like at this point here, you're going to be limited by 1. You come at this point, that's a 1 still. So the radius, or r, moves from 0 to 1. Okay, then what about our theta? Our theta moves from 0 to from 0 going up there, like that, in the y. So we are just more like picking our in terms of x. Then our y is going to be in terms of like our theta kind of thing. So we did that, we got our r, that's the furthest we can go. Then you observe to say our theta is going to start from 0 here. If you go up here at that point, that's going to be what, or if you don't want, you can start it from here. You're going towards what, this point, which is your pi over 2. So we're going to say our theta is from 0 to what, from 0 to pi over 2, which is 90 degrees. Okay, so this is actually the most important part about these questions. Okay, so it's being able to come up with the limits of integration. So for the theta, we said is from 0 to pi over 2. Then uh, just write it like this. So from 0 to pi over 2. Then for our r is from 0 to 1. Then here you have your x squared, but this will no longer be x squared plus y squared. I can actually write this in terms of polar, or in polar form. That's going to be r squared r dr d theta. Okay, so of which r by r squared, that's going to be r to the third. So r to the third dr d theta. We can go ahead and integrate the inside part. So that's going to be from 0 to pi over 2. Okay, when you integrate that, that's going to be r to the fourth divided by 4. Evaluate from 0 to 1. You have your d theta there, like that. So what is this going to be? So when you plug in 1 here, this is going to be 1 to the power 4, which is still 1. That's going to be 1 over 4, which is a constant. That's going to be 1 over 4 outside here. Then I have 0 to pi over 2 d theta. So integrate this part, that's going to be 1 over 4. You have theta, evaluating from 0 to pi over 2. Okay, so when you plug in this one here, this is going to be uh, pi over 2 itself multiplied by 1 over 4. That's going to be pi over 8, and this seems to be my solution. I'm hoping I'm right, but everything else that I've done, I believe, is correct. Okay, so let's go ahead to the third question, which is actually an interesting question. Okay, it's an interesting question. um, so this is how it's going to be. We are given this from -1 to 1. Okay, then what else are we given? We are given minus square root of 1 minus x squared. Then here you have 1 minus x squared, that's positive. And this question, I actually tried it using Cartesian. It's much easier in Cartesian. I'm not saying it's hard in polar, but for me it was like more straightforward in Cartesian. So you can try out both. You try just for the sake of understanding. Okay, so let's go ahead and sketch the limits of integration. So that's our vertical axis and that's our horizontal axis. So the inside part is for the y, so it's more like y is from minus the square root of 1 minus x squared, like that, to positive that. Then for the y, no, that's y actually. For the x is -1 to 1, like that. Okay, so let's go ahead and sketch these. So for these here, one thing that you're able to observe is that these are just circles. Okay, so for this one it's a circle, this one is a circle, then these are just lines. So when you sketch those, you're going to have a line here. Let me use different colors. You're going to have a line there and another line there, like that. Okay, then what does this now bring us to? So this is our y-axis, this is our x-axis. This is x is equals to 1, and this is x is equals to -1. Okay, then for this part, this part of y, I'll use red, and it's just more like it's a circle of radius 1 that is like on the top part. Then this one is on the bottom part. Let me use is yellow is going to be visible? Let me use black. It's like down there, like that. Okay, so the easiest part again that you can pick is the is the value of r. Okay, that's the easiest you can pick, because you're just moving from this point right here, and the furthest you can go from the origin is always 1, no matter the direction that you have picked. It's always going to be 1, because these what is limiting r is just the circles themselves, or the circle in itself, uh, of which both of them have a radius of what, have a radius of 1. Okay, so meaning r, okay, r is from 1, sorry, is from 0 to what, 0 to 1. Then what about our theta? Okay, so our theta, I think a mistake that you can make is just moving from 0 to what, to this point. Okay, so the best thing you can do is just move from 0 all the way back to 0 again, but don't say from 0 to 0. Maybe that can work, but I think it's kind of like more making sense if you say from 0 to what, 0 to 2 pi, like that, which is still, I think it's much okay like that. Okay, actually, whatever that I'm going to get here, I'll just try to work it out in terms of in Cartesian, so that I see if I'm still going to get one and the same thing. Okay, so as I said, this is going to be a pretty long video. Yeah, and see what we are going to get. So for this one, for the theta, it's from 0 to what, to 2 pi. Then for the r, is from 0 to 1, and this part is just going to be r dr d theta. Okay, so you observe to say this is going to be 2 pi uh, 0. When you integrate that, that's going to be r squared over 2. Evaluate from 0 to 1, that's going to be, you have d theta there like that. Substitute, that's going to be 1 over 2 outside, since when you put 1, that's going to be 1 squared, which is 1 over 2. So 0 to 2 pi d theta. What is this going to be? That's going to be 1 over 2. They are going to get theta from 0 to 2 pi, like that. So plug in 2 pi here. 2 pi minus 0, that's going to be 2 pi. So it's like 1 over 2 multiplied by 2 pi, which is going to just be pi as your answer. So we have gotten our solution as what? As pi. Let me try to do this. Just give me time. We are going to our last example, but before I do that, let me try to evaluate this in terms of Cartesian and see if I'm going to get the same thing. Okay, so if I integrate this here, I still have 1, negative 1 to 1. So integrating this, this is going to be y. Okay, with respect to y, that's going to be y. And you're moving from minus the square root of 1 minus x squared to the square root of 1 minus x squared, and this is still dx here. So when you substitute, okay, this is going to be the square root of 1 minus x squared minus this one, but it's going to be plus because of this negative that we have here. Okay, then that's the square root of 1 minus x squared dx. These two, they are the same, so you can add them, and that's going to be 2 square root of 1 minus x squared, of which I can just put the 2 outside. Then I move from negative 1 to 1. I have the square root of 1 minus x squared dx, like that. Okay, so what this one is going to be is this. It actually takes me to, it just actually requires me to use trig substitution, I think. From 0 to 1, let me see, from negative 1 to 1 rather, you have the square root of 1 minus x squared. Okay, so you still have your dx here. So what can work out for me here is using trig substitution. Let me say x is equals to sine what, is equals to sine theta, meaning dx is going to be equals to cos theta d theta. Okay, so this is going to be equals to 2 from negative 1 to 1. So I'm going to have the square root of 1 minus sine squared theta multiplied by dx. Your dx is cos theta d theta. This part here is nothing but what? Um, this is nothing but what is it going to be? This is actually cos theta as well. That's cos theta. So what this now gives us is this. We end up getting 2 1 over, sorry, from negative 1 to 1, then that's going to be cos squared theta d theta, like that. Okay, so what now do we end up getting? So by some identities, okay, so remember to say cos squared theta can be written as 1 minus, no, that's what actually 1 plus cos 2 theta divided by 2. So if I bring it right here, you observe to say these two and that two are going to cancel out. So just remain with 1 to negative 1. So negative 1 to 1. Then you have 1 plus cos 2 theta d theta. So after you integrate here, this is going to be theta plus sine 2 theta over 2. Okay, 2 theta over 2. 2 theta over 2, then this is from what? From negative 1 to 1. But you can actually take this back. You know, say your x is equal to sine theta, meaning theta itself is equal to sine inverse of x. Then you say plus sine 2, let me put them in brackets, that's going to be 2 sine inverse of sine inverse of x divide by 2, like that. Okay, so now we can go ahead and evaluate for from negative 1 to 1. So if you plug in 1 there, if you actually go to your calculator, if I say sine inverse of 1 is 90, which is actually pi over 2. But if you plug in 1 here, like sine of 2 sine inverse of x, or in this case 1, that's going to be a 0. So you're actually not interested in that part. Then you do the same for this one here. So sine inverse of negative 1 is going to be minus 90 or minus pi over 2. But because of this minus, you see minus pi over 2, this is going to be positive, so that's going to be pi over 2 plus pi over 2, of which that's going to be like 2 pi over 2, that's going to be pi, which is the same one that we got when we used Cartesian. Okay, so that's actually how we do it, and let's look at the last example. Maybe I think it appeared to be longer in Cartesian, but still all the same is still one and the same thing. So our last example is from 0 to 2, then 0 to x, okay, 0 to so this one is from 0 to x, okay, and the integrand is y, then we have dy dx, like that. So first things first, as always, let's go ahead and sketch the the region of integration. Okay, so in terms of y, we have 0, okay, y there, then we have our x there. In terms of x, we have 0, we have x, and we have 2 there. So all these are just functions. Here you have like y is equals to 0, and you have y is equals to x. Here you have x is equals to 0 and x is equals to 2. So you just have to come here. On x, I can plug in or just sketch my 2 there. Okay, something like that. Remember, this is my y-axis and this is my x-axis. So this right here is x is equals to 2. Then we have also x is equals to 0. Then something else that we have is y is equals to x, which is just this is an identity function, so you can just put it to be something like that. Okay, so this right here is y is equals to x. Okay, then this is x is equals to 0, and this is y is equals to 0. Okay, so remember our job is just to find the limits of integration, which is your r and your theta. Here is how we come up with our r. Here we have our theta, and this is more like our r there. How we come up with our r, always remember to say is still the maximum uh, distance away from the origin, or the furthest you can go from the origin. So it's still more like something like that. Okay, but keep in mind to say this is just more like limited by this line here, which is what, which is a 2. But you don't have to use a 2. Here's how we do it. 2 is the distance from this point to that point, but this one is not what, is not a 2. And here's how we are going to get what we have on the other side. Okay, so remember to say by SOHCAHTOA, cos theta in this case, cos theta is going to be equals to the adjacent, which is 2, divided by the hypotenuse, which is r. If you make r the sub of the formula, that's going to be r is equals to 2 over cos theta. And I don't want to use fractions, so this is going to be 2 sec this is going to be 2 sec theta. Okay, that's going to be 2 sec theta, like that. Okay, so what this tells us that our r is moving from 0, okay, to what, to 2 sec theta, like that. Okay, then what about our theta? Our theta, the lowest value of theta that we can pick, remember we're going in this direction, the lowest value of theta that we can pick is a 0. Okay, what about the highest value? The highest value that you're going to pick is pi over 4, which is 45. How am I getting the 45? What is limiting this line that is going up is this line here, which is y is equals to x. And this line here is an identity function, and it makes an angle of 45. You have 45 here and you have a 45 there, so it makes an angle of 45. So we write it in terms of the angle, which is 45, and that's how we get those. Okay, so let's go ahead and do the evaluation quickly. So how this one is going to be is that for the theta it will be 0 to pi over 4. Then for the r it will be 0 to 2 sec theta. Then here you have your what, your y. Then but instead of y, put it in polar. That's going to be r squared sine theta dr d theta. Why am I getting the square? It was supposed to be r squared, but I was supposed to have another r here. I'm just multiplied to give me r squared. That's where it has come from. So you can go ahead and do the integration. So we are from 0 to pi over 4. So integrate this with respect to r. You're going to get r to the third divided by 3, like that. Then you still have your sine theta, which is a constant. You are evaluating from 0 to 2 sec theta d theta there, like that. Okay, so this seems to be pretty simple from here. Okay, let's see what we are going to get. So this is going to be equals to from 0 to pi over 4. When you plug in 0 where there is r, everything is going to be 0, so you don't really have to worry about the lower limit. So this is going to be 2 to the power 3 is actually 8. So maybe instead of wasting time here, let me do this. I'll say equals, because when I plug in 2 there, that's going to be 8. So I'll write 8 over 3, like that, from 0 to pi over 4, like that. Then here you have you're going to have sec to the third theta by sine theta d theta. Okay, so now it's just a matter of us doing some manipulations for us to be able to work this out. Remember to say sec theta is equals to 1 over cos theta. So I'm going to strip one sec theta from that, so meaning this is going to be like 8 over 3. Okay, 8 over 3, you have 0 to pi over 4. This will remain as sec squared theta instead of sec to the third theta, meaning I have like divide by cos theta down here when this becomes a squared, and sine over cos, it becomes what? Tan theta d theta. How can I continue from here? So maybe the first mistake that I can make right now is thinking I need to substitute with maybe some trig identity or something, but that's actually not the case. So I can use u substitution. I can let u be equals to tan theta, okay, meaning du will be equals to uh, du will be equals to sec squared theta d theta. So your d theta is actually equals to uh, it's going to be equals to du over sec squared theta, like that. So this will be equals to 8 over 3, okay, 8 over 3 from pi from 0 to pi over 4. So you observe to say this will be cancelled out, so you just have like a u here, okay, you have just have a u du. Where there is d theta, I substituted with this, then you cancel you like we cancel out the sec squared. So integrating this, you have like 8 over 3. When you integrate u, that's going to be u squared over um, u squared over 2, evaluating from 0 to what? To pi over 4. I don't want to change back to what I don't want to change back to theta from u. So let me just find what it is. So I have u is equals to tan theta. So let me plug in those limits. So if you have the lower limit is 0, if you try to find what tan 0 is, tan 0 is still 0, because tan 0 is actually 0 over 1, which is still 0. So we still maintain the lower limit the way it is. What about tan 45? Okay, we say tan 45, which is like tan pi over 4, to give us our u. What will be our u? So tan 45, remember to say from this triangle here, okay, from this triangle we have like 1 1, the square root of 2, then that's 45, and that's 45. Tan 45 is just 1. So the upper limit becomes what? Becomes 1. So this is like, this will be equals to, you have 8 over 3, then you have u squared over 2 from 0 to 1. Plug in 1, this is going to be 8, this is going to be 8 over 3. You have 1 squared, which is 1, divided by 2 minus 0. So you observe to say that, and 2 into 2, 2, 2 into 8 is a 4. So your answer is actually 4 over 3. This right here is our answer for this question, and that's how we answer those. Thank you very much for watching, and we'll catch you in the next one.